Hi, so what we're going to do here is we're going to talk about inverse proportion. So, if as you increase one variable, the other variable decreases, this is described as inverse proportion. So, essentially the opposite of direct proportion, which was when if you increase one variable, the other variable also increases. So, inverse proportion very often, although not exclusively, deals with things that are to do with time. So, jobs that take a certain length of time are going to take less time if more people are working towards them. Or if you're dealing with a quantity or a variable such as food, something that's going to run out. So the best way to decide whether or not you're dealing with direct proportion or inverse proportion is really to think about the question, like actually really think about it, like think. So let's look at example one. If it takes 120 days, if it takes 120 days for 10 people to build a house, how long will it take 15 people? Well, if you think about that, it should take more people less time. Okay? So that should mean we're dealing with inverse proportion. And if you can remember the direct proportion, you'll be fine with doing inverse proportion. We just swap the order around of the operations. So we're going to find out how long it takes one person by multiplying 10 and 120. So hopefully what you can see is the process is pretty straightforward. It's just the complicated thing is recognizing that we've got inverse proportion. Because the question is not going to say, do this by inverse proportion. You're going to have to work out for yourself. Okay? So I did 10 people with 120 days. So one person was going to be 120 times 10, which gave you 1200 days. So it would take that one person 1200 days to make the house. And then 15 people will be 1200 divided by 15, which is 80 days. Okay, so like we say, we've got our number that is less than the original value, which is what we should do. So, 5 people build a wall in 1 hour. How long will it take 8 people? So again, 8 people should take less time. So we started with 5 people equals 1 hour. I could see that I didn't really want to deal with 1 hour because it was going to end up with a decimal, so I changed it into 60 minutes because that's going to be easier to deal with looking at the units. It's not always going to be that case, but we want to work in units that are going to be convenient. One person is going to be 60 times 5, which is 300 minutes. It would have still been fine here if we kept it in hours, because we'd have got 5 hours. But then with 8 people, we'd have had to do 5 divided by 8, and we'd have dealt with decimals. But since I changed it into minutes, it's 300 divided by 8, which is 37.5 minutes for 8 people to build the wall. Okay? So last example, we've got 10 people, and we've got enough food to last 6 days. How many days will the food last 12 people? So again, if you've got more people living off the same quantity of food, it's not going to last as long. So it's going to be inverse proportion. So let's find out how long it takes, how much one person will have food for, and then we can do 12 people. So there we go. We had 10 people lasting 6 days. So one person would be 6 times 10, which is 60, and then 12 people would be 60 divided by 12, which is 5 days. So that food supply is going to last 5 days for 2 extra people. Okay? So the process is straightforward, but the contextual understanding of the question can be quite tricky. So if we just think about the question logically, think about it in real life, is this going to be direct proportion, or is this going to be inverse proportion, and you'll be fine. Okay? So that is inverse proportion.